All right, the remainder theorem. So the remainder theorem, I wish I knew how it applied or why it would be useful, but I can't. We're still going to use it though, okay? So that may not make sense right now. Just understand your remainder, it says P of C is the remainder of, or P of C equals the remainder. So that means that if your function was whatever it is, right? X, let's just make something up here. So if you're, I don't know, that's so thick, but so you got x cubed plus x squared plus 5. I don't care what it is. And let's say this was f of x equals this. Well, if you were for some reason wanting to divide this by, let's say, x minus 2 right there, right? The remainder of f of 2 would be the same as doing the long division here, or the synthetic division with, and then finding that remainder.
Right, with f of 2 you cannot do that.
That's true. What they'll say is, here's what they'll say. They'll say, using this function, use the remainder theorem to find this. And then what you do is you'd say, well, okay, that's fine, that's fun, because then I can use synthetic division again, and we love it so much. But then you say, well, I see it's f of 2 right there, so you put 2 in the box, and then your coefficients again. You got 1, 1, 0, and 5. I skipped some work there. Then you do some synthetic division. So 1 times 2 is 2. There's 3 times 2 is 6. 0 plus 6 is 6. 6 times 2 is 12. And then 5 plus 12 is, what do you know? It's 17, right? What it's saying is that if you were to replace these x's here with 2's, you'd get 17. Now, as awesome as that sounds, right? Like, wow, are you serious? I can do that with my life? Yes, you can. But in the past, we would say, just replace the x's with the 2,
Right.
And then be done with it. Unfortunately, or fortunately, however your perspective is, if they say use the remainder theorem, they want to see this stuff right here. F of -1. Now again, f of 0 and f of 1, all of these, I would just say, hey, let's just replace the x's with -1, 0, and 1, and then use the calculator from there. Which, if you do that, by the way, remember for your x squareds especially, put the negative 1 in parentheses. Otherwise, it will give you the correct calculation, but you've told it to do the wrong thing, the calculator, okay? All right, well, to start us off here, we got a -1. Now, again, you could plug that in, or you could use synthetic division, which is what I'm going to do. So I've got my synthetic division. I'm going to do this fairly quickly, so just be aware. It's f of -1, so again, that goes in the box. Then I've got my coefficients of 3, -6, and 3. Okay, so let's get started here. We got drop the 3. 3 times -1 is -3. -6 minus 3 is -9. -9 times -1 is 9. And that'd be 3 plus 9, which gives me a remainder of 12. And that remainder right there is what f of -1 is. Boom. Now you can check, right? You could say, well, what is 3 times -1 squared minus 6 times -1 plus 3? It's going to be 12. You see, now you're like, oh, I'm now intrigued. I don't think you are, but you can say it. All right, so we're going to do this again, but now my C value is 0, so we put a 0 there, and that's okay. Same coefficients, though, of 3, -6, and 3. So again, we'll just continue here. We'll drop the 3. 3 times 0 is, 0. -6 plus 0 is -6 times 0 is 0. 3 there plus 0 would be, 3. So f of 0 is 3. And again, if you come up here, you say, well, what if you replace the x with zeros? You get 3, and that one's a pretty quick calculation. Finally, right here in this one, we have an x value or a c value that's 1. There's the 1. Same coefficients of 3, -6, and 3, but new calculations, right? So we'll drop the 3. 3 times 1 is 3. -6 plus 3 is -3. -3 times 1 is -3. Okay, I didn't expect that, but the remainder here is 0. So f of 1 would be 0, which again, if you replace these x's with 1s, you would find that it would be 0. Boom. And that is how you apply the remainder theorem to this kind of context. So the ones that we've done before, we could have done it like this. But I don't know if you wanted to do it now or then. So there we go.